Okay, so transformations of sine and cos functions. So this is pretty much exactly the same as last year, but again, we're dealing with now radians instead of degrees. So when we look at a sine or cos function, or really any function for that matter, sine and cos is a little bit different, but A is the vertical stretch and compression. And because it is a periodic function, A is going to give us the amplitude. Okay, so that's the amplitude. Now the K value actually tells us the period. Now, normally it would be 360 divided by K would tell me the period, but in this case we're using 2 pi, so this is going to tell me that the period of the function is equal to 2 pi divided by K. Alright, now when we're dividing by something like a fraction, like 2, that's 2 pi divided by a half, that would be actually multiplying by 2, so remember that's flipping the fraction. C is our horizontal shift, or our phase shift. And D is our vertical shift. I guess we'll throw in horizontal. Alright, so if I'm looking at these functions at the bottom here, we're just asking what's going on with them. The amplitude of the first one is just the A value, so it's just 15. Those are just in units typically, so we would have the units on the side. Depending on the problem, you might change those units, but when we're just graphing the function, you're just graphing in units, not any specific unit. Period is going to be 2 pi divided by our K value, so divided by 2. So our period is just pi. There's no phase shift because there's no value in the middle there. And it's down 12 because that last value is down 12. All right, over here our amplitude, that negative doesn't have anything to do with our amplitude. The amplitude is just how far it is from the top to the bottom divided by 2. That negative is just going to flip the way we start the graph. So the amplitude here is still 5. Now the period's a little bit harder. I'm going to actually just write it up here because I don't really have space. But what we need to do is we need to have our function. I'm going to actually change that. So let's write it in function notation. So we've got f of x equals -5 sine. We actually need to, and we did this before, we need to factor. So we still have that 2, but our phase shift would be a little bit different, and a lot of people would miss that right off the bat. So our period here, again, it's going to be 2 pi over 2. We're going to have pi. Our phase shift, and announcement, our phase shift is going to be 3 to the right, which isn't very realistic using a sine function, but that's okay. And then our vertical translation is up 8. Okay, so looking at this graph, and I know there's a little bit at the bottom of these next two, the next two graphs, the graphing using mapping notation. I'm just going to show you kind of how I do it, and then we'll use the mapping notation potentially in class. But when I'm graphing these, first I need to find out what my period is, and then we need to establish a scale. Now typically your scale going up the graph, I would do like every other square is a value. So we've got 1, 2, oh, in this case I can't even do that because we're going to have to get up to 4, we have to get to 6, 1, 2, 3, 5, and I wouldn't, so I'm going to go 2, 4, 6, 8, -2, -4, -6, -8. Okay, so we've got that. Now we want to count probably by pi by 6. Okay, each square should be pi by 6. So if we have each square as pi by 6, that means that the third square would be 3 pi by 6 or pi by 2. The 6th square would be pi. The 9th square would be 3 pi by 2. And the 12th square would be 2 pi. and so on. So then your next one would be 5 pi by 2, and it would continue. So then 3 pi, and we'll stop. And it's going to go the exact same thing on the other side. So we've got negative pi by 2, 1, 2, 3, negative pi, 1, 2, 3, negative 3 pi by 2, 1, 2, 3, and negative 2 pi. And that's where I'm going to stop. Okay? So we're graphing one cycle, so that's why I'm kind of stopping there. All right, so looking at this, we've got an amplitude of 4. Our period, there's no k value, so our period is just going to be 2 pi. Our phase shift, again, there's no phase shift because there's nothing inside the brackets there. So we have no phase shift, none. And vertically, we're going up 2. So what that means is the reason that I knew my scale wasn't going to work is because I've got an amplitude of 4, and I'm starting up 2. So that means I'm going to have to do 2 plus 4. That's going to get me to 6. So when we're graphing this, the way I would graph this is I always do my phase shift and my vertical translation first. So I've got up 2. I haven't moved anywhere else. I'm going to go one period over from that. So I'm going to go right to the end. I'm still up 2. Okay, now I'm going to cut that in half because in the sine function it goes right through the middle halfway. So I cut that in half. Because it's a positive sine function, okay, at the start, I'm going to cut the first half of this, so right here, I'm cutting that in half again, and I'm going to go up by my amplitude. So I'm going to be at pi by 2, I'm going to go up to 6. Then I'm going to cut the second half in half. I'm going to go down by my amplitude. So at 3 pi by 2, I'm going to go down 4. I'm going to be right there. And then I'm just going to, in a curve, connect my dots. And it says to only do one cycle, so I can stop. If I wanted to do more, I would go back one period from the starting point. So I'd go back to 2 pi. I would cut it in half. I would go down by my amplitude. I would go up by my amplitude. Where am I? Right here. And I could continue on my graph. Okay? I'll do the next one, and I'm going to leave the last one for you guys to do on your own. Okay, so here we've got an amplitude of 3. We've got a period, again, of 2 pi. We've got a phase shift, and if you look, it's in radians. We can see it's pi by 3. Now that's going to change our scale a little bit. So we're going to go left, or negative, left, pi by 3. Okay, no vertical translation, so that's a little bit nicer. If I'm going left pi by 3, it's still nice sometimes to do counting by pi by 6, and that's going to allow me to. So if I count by pi by 6 again, that means every 2 squares is going to be a pi by 3. So I'm going to still go back here to negative pi over 2. I'm going to go on the other side to positive pi over 2, pi, 3 pi over 2, and 2 pi. Here, I'm going to have the same thing on the left-hand side, so negative pi, negative 3 pi by 2, and so on. Okay? Going up and down here, because we're just going up 3 or down 3, we've got 1, 2, 3, 4, negative 1, negative 2, negative 3, and that'll be plenty. Why not put negative 4? Okay. Now remember, a coast graph always starts at the maximum, or in this case, it's going to start at the minimum because it's a negative value. So what I'm going to do is either think about starting at a different point and make it a sine graph, or I'm going to go back. Sorry, there's no translation here. I'm going to go back by pi by 3. I'm going left pi by 3, which if you think about pi by 6, it would be pi by 6, 2 pi by 6. Well, 2 pi by 6 is 1 pi by 3. I'm going to go down 3, put my starting point. Now my period is 2 pi. So I'm going to go from that point, I'm going to go to 2 pi, which is really just 2 squares back from the end. Okay, the end was 2 pi. If I go 2 squares back from that, because I've made a good scale, I'm going to be able to find my 2 pi away. So I'm right here. Now this time, if I cut it in half, I have to go up twice the amplitude because it's a cosgraph. So I'm going to cut it in half, which is going to be 2 squares back from pi. And I'm going to go up by my amplitude from the midpoint. Now if I cut those values in half, I'm going to be right on our axis, and there's my graph. It says 1 cycle, so I only have to do 1. If you wanted to, you could obviously continue the cycles on, but that's what the graph is going to look like. It's got a good scale, it's got arrows at the end, it's got 5 points. When you're graphing with me for trig functions, you need to include 5 points. Okay? The points are the starting point, the end point, the midpoint, the first quarter, and last quarter. Okay, again, I'm going to leave this one with you. The change for this one, the amplitude's changed, it's a sine function. The period has actually changed, which is going to change your scale. It's going to make it a lot smaller in this case. So I want you to notice that. There's no phase shift or vertical translation, so it should be quite easy to graph. Okay, make a good scale, and it's an easy graph. Okay, the last one, using mapping notation, give me the key points for this. So the key points, the way we're going to use mapping notation, so you've got the first point, last point, midpoint, quarter point, quarter point. Okay? I'll go through this in class with everybody. I don't think that it's something that I want to show you on the whiteboard here, but it's not that difficult. Okay? It's the same as what we've been doing before. Again, I'll go through it in class tomorrow. We have to take up a couple things and take up our tests, so we've got a few things to cover.